Hello and welcome. In this tutorial, we'll study about memory management in Java. Memory in Java. Basically, the memory in Java can be subdivided into two parts, that is heap and stack. So both are a part of Java memory, but both has highly different type of objects that they can contain. So let's see each of them one by one and see what they can actually have. So firstly, let's talk about the heap memory. So heap is used by runtime to allocate memory to objects and GRE classes. So at runtime, whenever you create an object, it is always stored in your heap memory. Fine. Then object is always created in heap, definitely. After that, garbage collector runs on heap memory to free the memory used by object that does not have any reference. So you see, like the garbage collector actually runs on heap memory. That means it always runs on heap, and what it does, it frees those objects that are not having any reference, and thus, remove those objects, and thus basically it's freeing your memory. So that's the purpose of garbage collector. Now, object created in heap space has global access. That means it can be accessed from anywhere. So it need not be there like, if a object is in a package and other one is in different package. But if your object is created in a heap, that means it has global access. So that memory can be accessed anywhere. Although you must have a reference to it, that's the other way. But it can be accessed globally. Then it can be referenced from anywhere of the applications. Just said that it can be accessed anywhere from your application. After that, let's see about the stack memory. What is stack memory and how it is used and how it differs from the heap memory. So stack memory is used for execution of threads. Well, so when we say execution of threads, like, in Java we do have multiple threads, like even if you're not creating your thread, then even your, the main method that you create will have its own thread. So each method in Java have its own stack trace. Why so? Because each method actually kind of creates its own thread. So each thread of execution will have a own stack memory. Okay. After that, the stack always follows LIFO. LIFO means last in first out. That means, like, for example, there is a consider a case of CDs. Then how do you pile those case of CDs? You insert one of that, on top of that you insert remaining, and so on. So if you want to remove, how do you remove that? So whatever is there on top means whatever you have inserted in the last will be the first one to get removed. So that what the LIFO stands for. That means last in will be first to out. So last in first out is a rule for stack. So this is how stack works. They have just one open end. So whatever has been placed on the stack on the top, so that is the element that will be removed first. Now whenever a method is invoked, a new block is created in stack memory for methods to hold local primitive values and references to other objects in the method. So you see that whenever a method is invoked, a new block is created in stack memory for the methods to hold the local primitive values and reference to other object in the method. So this is how it is invoked. Fine. So you have to, have a new block is created in the stack memory, and that can actually hold local primitive types and reference to other objects. Whereas all the objects are created in heap. So your stack will only contain local primitive values and references, and also the methods which have been called. These are the things that stack memory can contain. Now, as soon as the method ends, the block becomes unused and become available for next method. So you see, like whenever there is a method, let's say even in the method there is a variable. that variable is declared inside a for loop. So as soon as the for loop ends, now that block becomes unused. So the variables declared inside for loop will be removed from your stack memory thereon. Okay, so this is how it will be removed. And it will be removed in the LeFo fashion, that is last in first out. So after that, as soon as your complete method ends, then all the local variable of that method and that method from the stack will be removed immediately. Okay, so this is how the method will be removed from stack. Now stack memory size is very less as compared to heap memory because stack is a very small memory as compared to heap. Okay, now Java heap. The heap is divided into two areas, which is nursery and old space. So nursery is also called as a young space. Okay, and they can also be called as generation, like young generation and old generation. Okay, so this is like the division of the heap, Java heap memory. So actually, if you see physically, it's whole single memory, but virtually we kind of divide it in nursery and a old space. So let's see what's the nursery, that is the young generation is. Well, the young generation is a place where all new objects are created. When young generation is filled, the garbage collection is performed. So whenever a new object is created, it is always stored in young generation memory. That is your young memory. Okay. So you see that whenever your young generation is filled, the garbage collection is performed on that. So the garbage collection is called as the minor GC. So garbage collector that runs over here is actually called minor GC. Then young generation is divided into three parts. So those three parts are like hidden memory and two survivor memory spaces. So these are, you can say, the division that we did for the young generation memory. So we have divided that into three parts: hidden memory and two survivor memory spaces. Fine. So this is a division that we have did. So in a way, how it happens is like, whenever there is a object in young generation and it has been used for a very long time. Let's say it's been there for a very long time, and your young generation is meant to keep that object for a short time. So if some particular amount of time has elapsed, then that object is actually moved to the old generation. But let's say before that time elapsed, the object become unreachable, then the garbage collection is performed to collect it, and it is called minor GC. Now, all objects are very short-lived in young generation. Why so? Because it's a small part, So nursery is a small part as compared to the old part. So it's kind of work as a cache. So how the things happen in cache. So whenever you do something, your web browser history or anything, it gets stored in a cache. And whenever you have to like reopen a page, then it's small and it's faster to access. Thus, your web pages and all the things that take time to buffer or browse get opens very quickly. That's because it's stored in a cache and that can be accessed easily. And once, although sometime automatic deletion do not take place, you have to manually delete it, but just relating it with the young generation. So let's say now when your use has become over, then your garbage collection could be able to remove that. And let's say if some time has elapsed and still the object is alive, then it can be moved to your old generation space as well. Now, therefore, the objects are short-lived. After that, swift at finding new allocated objects. So young generation is definitely swift at finding objects. So as I've said, like, give an example of a cache memory where it is a small memory and it is easily accessible because RAM is a huge memory. So it's difficult to hide, things in that because it does take time to get the things from RAM, but from cache it's really quick. So in similar way, from young generation, it's very swift to find the newly allocated object as compared to old generation. Then freeze memory faster than old generation. Obviously, there is a time given, like if that time the object reference is not present, it's got finished, then it just frees the memory and garbage collector runs very swiftly onto this memory. Now let's see about the old generation, where the old generation memory contains the object that are long-lived and survived after many rounds of minor GC. Usually, garbage collection is performed in old generation memory when it is full. Old generation garbage collection is called major GC and usually takes longer time. So you see over here the objects are long lived, okay, and it is called major GC, and it is performed when old generation memory becomes full. So therefore it's not very quickly performed, it takes time because old generation is a big memory. Okay, and definitely it takes time to perform garbage collection over here as compared to your young generation memory. Some of the model of garbage collection. So, garbage collection do happens on basis of different model, but it's not like, each and every JVM follows this model, but we are covering this model in our tutorial because it's one of a very basic model and most of the JVM does follows it, not 100%. So it's called mark and sweep model, and mark and sweep garbage collection model performs garbage collection on whole of the heap. So it is used to perform garbage collection on heap. Then it has two phases, which are mark and sweep. Now let's see what these two phases are and what they do. So let's see firstly the mark phase. In mark phase, all objects that are reachable from Java threads are marked alive. Okay. So whichever objects that can be reachable from Java threads are marked. Now this process identifies and marks all objects that are still used. So whatever we are using, it will mark that. And rest can be considered as garbage. So this is how mark phase works, marking those that are still in use and so that remaining can be considered as garbage. Okay, so once marking is done, then the sweeping phase occurs. So in the sweep phase, the heap is traversed to find gaps between live objects, and these gaps are recorded in a free list and are made available for new object allocation. So you see, like there must be, gaps. Heap is getting traversed. Then after memory 101, there could be a gap of 102 and 103, and then 105 is accessed. Okay, so these are like gaps which are not filled memory. So in sweep phase, these gaps are actually recorded in a free list so that they can be made available to new objects by compacting. So there is a process called compaction in which all those free lists are compacted so that the memory could be made available for the other or new object allocation. Now, mark and sweep model has two versions. When we say version, so we can call it as, they can be performed in two ways. So one is concurrent mark and sweep and other is parallel mark and sweep. Now let's see what is the difference between the two. So firstly, let's see what is concurrent mark and sweep model. So concurrent mark and sweep model allows the Java thread to continue during large portion of the garbage collection. Okay. So for large portion, it is very useful. Threads must, however, be stopped a few times for synchronization. So it can be performed in a running thread, but you need to pause your thread for some time for the sake of synchronization. Okay, now let's see. So in concurrent mark and sweep model, your marking phase actually internally has four phases. Now let's see what these four phases are. So the first phase is initial marking. So initial marking, what it does, it root set of live objects is identified. So we identify the direct references to your live objects. Okay, so those are actually marked. After that, we have concurrent marking. So in concurrent marking, reference from the root set are followed and marked. So whatever references we have, like second-hand references or the third-hand references, or maybe the first-hand references, all those are marked in the concurrent marking phase. Okay, so these are definitely followed from root set, and thus if we find there are references also, then we mark them. Then we have pre-cleaning. In pre-cleaning, changes in the heap during concurrent marking phase are identified and additional live objects are found and marked, and threads being running. So you see, like whenever a thread is being running in a running stage, at that time pre-cleaning happens. So in this stage, during performing the concurrent marking, if there happens to be any change in the heaps, so those are identified, and additional live objects, if they are found, then they are also marked. So this is about pre-cleaning. Then let's see what is final marking. In final marking happens when the thread is being paused. So whenever thread is paused, at that time the marking happens. In this, the changes during the pre-cleaning phase are identified and any additional live objects are found and marked. Fine. So you see if there is any additional object that is found and that will be marked. That is called final marking. Fine. So they were four phases of marking. Now let's see the four phases of sweeping. So the four phases of sweeping in concurrent mark and sweep model are: firstly, sweeping of one half of the heap. So we actually sweep one half. After that, there is a short pause to switch the halves of the sweep, and then sweeping the other half of the heap. So then we actually sweep the other half of the heap. After that, the short pause for synchronization and recording and statics take place. So we actually need to record the statics and do synchronization. So we take the pause for that. So the pause activity happens when the thread is in pause state, and sweeping happens when the thread is running. Okay, so this is how sweeping is done in the four-phase concurrent mark and sweep model. Now let's move to parallel mark and sweep model. Well, parallel mark and sweep uses all available CPU in the system for performing the garbage collection as fast as possible. So this is the faster as compared to concurrent, and it uses all available CPUs in the system, so it occupies the CPU but it is fast, so it's quickly performed. Then all Java threads are paused during the entire parallel garbage collection. So it will pause all your threads and thus perform your parallel garbage collection. So this is how parallel garbage collection happens in Java. So definitely we have studied it's very swift as compared to concurrent, and it occupies all CPU memory and all threads are in pause state. Okay guys, so thank you very much. It was about the memory management in Java. Hope you have enjoyed this tutorial. Now let's meet in the next tutorial. So stay tuned in and thank you.